this 10% relationship of the actual render resolution. So if we go to the camera view, you can see there we have our particles. I'll just hide the particle view for a second, and you can see they've all pretty much got the same kind of scale. Although, as I said, you know, all of these particles are at different distances to the camera. So you can see it's actually using this percentage value to define their scale to the camera, and you can see they're having to orientate themselves towards the camera as well, which is why, as I said, use parallel direction doesn't work. So you can set these up to be whatever scale you want them to be, based, you know, as I said, as a percentage of the render resolution. If you change the render resolution, that doesn't make any difference. You know, the proportion will maintain itself. And the only other option you have in this one is you can see you can actually vary the percentage. So if we put in a slight variance in the percentage, this is just a random value. And as with other operators, you know, if you want to change those random values, let's just make that a bit more random. You can change the seed down here, so you can actually vary the random value here. So I'll just put that back to 0, put that there. So that's it for the actual size of the facing particles. If I do a quick render, there we go, you can see all the particles. I'll actually go into the material for a second and just put that the specularity down to 0, put the self-illumination up, do another render again, and there you go. You can see you've got these facing particles. They're all facing towards the camera, and they're all using different frames from the animation which I've mapped onto them. So as I said, the example animation that I've actually used is not necessarily the best example that you could ever have, but a typical example of what you would use facing particles for would be doing fire, where you'd use additive transparency, and you know, you'd map on animated images of fire onto particles, and that may not actually sound very effective, but it was used to great effect in the New Line Cinema trilogy that was out obviously over the last few years, Lord of the Rings, and pretty much everybody's seen the Balrog sequence, and all the fire in that, as far as I understand it, was done with a combination of small particles creating sparks and things like that, you know, little embers coming off, but the body of the fire actually was pre-filmed fire elements that they actually created at Weta, and then they mapped those onto particles, and they had those particles emit from the surface using facing geometry, and then that produced the effect of fire. The trick was that they actually had lots of different fire elements, so you didn't get any sort of repetition, and they also used specific fire elements for specific parts of the fire. So, you know, obviously different parts of the body would have different size of flames, and the flames would behave in different ways, and they basically very carefully chose how those textures were used on the particles, and you know, it was very effective in the film. It works very, very well. It's actually one of the few times I've ever seen particle fire done where it actually looks completely realistic. So it's a very good example of using facing shapes to do very realistic effects. As I said, you can do snow, you can do lots of different effects. You know, you can also use it for obviously non-realistic effects, like you can have cartoon characters on there if it's you know, for a child's television channel, or you know, things like that. So it's very flexible, and it's a very common technique in CG. Obviously, the main thing you've got to do with these facing particles is it's very important you get the transparency map on them to be, you know, accurate, and that's one of the main problems. The other thing you probably want to do is you want to make sure that your specularity on the particles is also mapped, so you don't get any specular highlights in what are effectively the transparent areas. That's a common mistake that people make. They map the transparency, so you know, you get a shape on the particle, but they don't map the specularity of the particle, so you actually get highlights in areas which actually shouldn't be visible. And obviously with certain types of effects you don't want highlights anyway, so that's another thing you can do. Actually turn off any sort of specularity in the material. So with that being said, let's carry on with the rest of the options in this particular operator. Just go back to a perspective view and move the camera over here a little bit. Okay, and we can see that we have a pivot at parameter. What that does is it defines where the pivot of the facing shape object is. Now the default option is for it to be in the center of the particle, which is generally what most people want. You have the option for it to be at the top,